Welcome to episode 18 of CipherVibe's end-to-end cloud security architecture course. CI/CD pipelines are software factories with privileged access to source, dependencies, artifacts, cloud accounts, and production deployment. Securing them protects both the supply chain and the infrastructure they control. We will connect its purpose, design boundaries, implementation path, failure modes, and evidence of effectiveness. Every cloud security layer relies on the ones around it. Pipeline security uses machine identities, secrets, code analysis, artifact integrity, IAC checks, and runtime deployment policy. It supplies evidence that a released workload came from an approved source and process. Treat the architecture as a chain. A trusted identity requests an action, a policy makes a decision, a workload or data service enforces it, and telemetry records enough context to investigate later. The first building block is protect runners and execution context. Use isolated, ephemeral runners for builds and deployments, separate untrusted pull request execution from trusted release workflows, and restrict which branches, tags, and approvals can reach sensitive credentials. Treat runner images, caches, plugins, and network access as supply chain assets. The second building block is inject secrets safely. Use identity federation or short-lived tokens so jobs retrieve only the secrets and cloud privileges required for a stage. Prevent secrets from entering logs, artifacts, caches, or developer-visible variables, and revoke access quickly when a workflow or integration is compromised. The third building block is produce trustworthy artifacts. Generate an SBOM, sign artifacts, capture build provenance, and store releases in protected repositories. Verify at deployment time that the artifact came from an approved workflow and has not been replaced, retagged, or mixed with an unreviewed dependency. The fourth building block is gate production deliberately. Protect production environments with scoped deploy roles, review gates appropriate to risk, change records, and a tested rollback plan. Verify the deployed version, configuration, health, and security controls after release. A successful pipeline status is not sufficient evidence of a safe change. Use this reference pattern. Begin with an explicit policy that describes the permitted outcome. Enforce that policy at the closest reliable control point. Route decision and activity evidence to protected storage. Then give an accountable team a tested path to review exceptions, correct drift, and respond to violations. A secure delivery pattern isolates build execution, grants stage-specific short-lived authority, signs and records the artifact, and deploys only verified releases through an accountable production gate. Implement this layer in a sequence that preserves evidence and limits blast radius. First, inventory workflows, runners, secrets, integrations, and deployment targets. Second, separate untrusted builds from release-capable workflows. Third, replace static pipeline credentials with federated identity. Fourth, generates bombs, signatures, and provenance for releases. Fifth, enforce protected environments and post-deploy verification. Prefer pilots with a named owner and rollback plan over an unmeasured organization-wide switch. The best rollout is one where a normal workflow succeeds, an unsafe path fails closed, and the team can explain the decision from logs rather than intuition. Security architecture fails most often through assumptions, not dramatic movie-style attacks. First, running untrusted pull request code with production secrets. Second, reusing broad cloud credentials across every pipeline stage. Third, treating an artifact tag as proof of provenance. Fourth, allowing manual deployments that bypass the audited release path. A configuration screen is not assurance. Collect evidence that the intended control applies to the correct scope and that violations become visible. First, test a pull request workflow cannot reach production credentials. Second, measure signed artifact and SBOM coverage. Third, review runner isolation, plugin risk, and secrets exposure. Fourth, exercise rollback and deployment denial for an unverified artifact. Test both normal activity and a safe negative case in an authorized environment. Record the expected decision, the evidence location, the owner who reviews exceptions, and the rollback method. Repeat after platform changes, new integrations, or major shifts in business use. For a practical exercise, design a release pipeline for a fictional cloud API that signs an image and uses a short-lived deployment role. Use synthetic information or an environment you own or are explicitly authorized to administer. Deliver a one-page diagram, a concise control statement, a list of expected audit events, and one test for an allowed path plus one test for a denied path. This artifact is more valuable than a screenshot because it explains the reasoning behind the configuration. Before scaling this layer, ask 5 review questions. Which assets, identities, or environments are in scope? Who owns the desired state and exception decisions? Which enforcement point can reliably apply the rule? Which records prove the decision and retain enough context for an investigation? And how can the organization revoke access, contain impact, or roll back safely when a control fails? Good architecture makes these answers explicit and testable. The key lesson is that CI/CD pipeline security becomes dependable only when design, policy, enforcement, evidence, and ownership move together. Document the decisions you make, remove permissions and exposure that do not support a real requirement, and rehearse the paths that matter before an incident forces the lesson. Continue through the next episode to connect this control layer to the rest of the CipherVibe cloud security architecture.